Translations on the Cartesian plane. Often we are asked to translate, rotate, or reflect shapes on the Cartesian plane. Cartesian plane being the regular coordinate axes that you know and love. It's called the Cartesian plane because it's named after the man who is attributed with the invention of the coordinate grid, René Descartes. So you can see that Cartesian is derived from his surname. This allows us to give the original coordinates of the vertices and the coordinates of our vertices for the translated shape. When point A is translated, we call its image A dashed. So that's just as we saw before for entire shapes. So A dashed, which we can see just here, is the image of the point A, and so on. In this example, the coordinates of the original shape are as shown here. For the translated shape, we call the coordinates A dashed, B dashed, C dashed, D dashed, and E dashed, and those are the images of A, B, C, D, and E respectively. So A dashed is the images of A, and B dashed is the image of B, as discussed. We want here to give the coordinates of the translated figure. So in other words, we've got to find A dashed, B dashed, C dashed, D dashed, and E dashed. So A dashed I can see is at 0, 3. B dashed I can see is at 1, 2. C dashed is at 1, 1. D dashed is at -2, 1. And E dashed is at -2, 3. Now we're not asked for it here, but we could give the translation vector. So let's just choose a point like D. So D dashed is the image. What have we done to get to E? We've gone 4 units that way and 5 units that way. So that means that the vector would be 4, 5. So -4 because we went left, and 5, +5 because we went up.